variables. And I'm gonna re-record this. I gotta record this. Yeah. These notes have changed. So it says consider the differential equation dy dx equals 3x squared over e to the 2i. So this is kind of cool. This is just a little bit of a view of what ordinary course on ordinary differential equations would look like. It follows after Calc 3 on the semester system. It's not any more difficult than Calc 3. It's actually pretty easy after you've had pre-Calc 3. It's not that hard of a course. So consider the differential equation. What you learn in that course is how to do mathematical modeling with differential equations and how to find particular solutions. Either with, there's certain methods. We're going to learn one method. In Calculus AB, we learn only one method. It's called separation of variables. That's it. It's the only one we learn. So that it's pretty predictable in terms of the AP exam that they'll have this on there. Is one of the pre-responses. So here's the equation. Write that down. It's dy dx equals 3x squared over e to the 2i. And we are going to find a solution, y equals f of x, to the differential equation satisfying f of 0 equals 1/2. And this was taken off of an old pre-response from an AP practice exam back when my first round of teaching, the first 9 years, somewhere in there. First round of round teaching. So we're going to find the particular solution. Or another way, find the equation for the initial value problem, that type of thing. So here's how the separation of variables step works. You just get the independent variable with the independent variable, dependent with the dependent. In this case, it's the y with the y and the x with the x. So it's a little cross multiplication step. And typically this process right here, this part A, is maybe worth 5 of the 9 points on the free response of the AP. And then maybe a couple points for drawing the slope field. And then maybe a couple points for sketching a particular solution, or for finding the domain, and maybe even the range of the function. Usually it's just the domain. Range can be hard. We'll talk about range on here. I don't know if we'll do it, but we'll do the domain. So here we have e to the 2i. E to the 2y dy equals 3x squared dx. So that is the separation of variables step. 1 point for that out of the 5. Next step. What do you think you do on each side? Integrate it. Integrate each side. This will be the next point. So integrate it, and then somewhere we got to stick a constant in here. But integrate each side. Yeah. So what is the integral of e to the 2y dy? You match it. This is the best one. You match it, but instead of multiplying by the derivative of the power, you got to divide by the derivative of the power when you're integrating. If you want to, you could use a u substitution. This is where u sub comes in. You would let u equal 2y, du would equal 2 dy, and you'd have to put a 1/2 out in front and a 2. Hopefully we can kind of avoid that with exponential functions. You're going to be integrating a lot of these. So using your u substitution, or looking at it, we've got e to the 2y over 2 equals, that's the other thing I should have done here. Here's the other thing I want to do. Might be helpful. On the right-hand side, the side with the constant, it's actually really nice to only have a variable. And so oftentimes what I will do is see this constant of 3. I would move it with that. So I'm going to do that now. It will make it a little bit easier when it comes to evaluating for C. Okay, so I would always do that. As a matter of fact, if you can, on that right side is where we're going to put the constant. If you can get rid of all scalar multiples, it's a really good idea. So let me move this 3 over here as well. Just go like this. Move it, make it 1/3 over here. And we'll erase the 3 from here. So go ahead and do that. So then now we'll have right here, this will become, I'll write it down so we don't lose it. There's the 1/3 right there. Okay. And then the integral of x to the second is 1/3 x cubed. So, and then plus c. All right. So how do I find C? So this would be the third point. Plug in your value that it goes through. So we're going to plug in 0 for x and 1/2 for y, which is nice. So we've got, this becomes e to the 2 times 1/2 over 6 equals 1/3 0 cubed plus c. So c equals what? Looks like it's just 1/6 e to the first. It's just e over 6. All right. So now, so that's 3 of the 5 points. And then what we're going to do next is rewrite the function. So rewrite my function going up here, or even right here, I guess. So we have e to the 2y over 6 equals 1/3 x cubed plus e over 6. So that's my function. And it depends. They may ask you to solve for y. We can do that. We can solve for y here. It comes out okay. But essentially, I have an equation. This is just in an implicit form, right, as opposed to explicit. We're going to need to get it in an explicit form to answer the question about domain. So let's go ahead and get it into an explicit form. Do you remember how to solve for y when y is a variable power? Yeah? Okay, go ahead and do that. Do that. You're going to multiply through by 6. I got some algebra to do here. Multiply through by 6. I've got e to the 2y equals 2x cubed plus e. And then I'm going to ln each side. So take the ln of each side, ln of e to the 2y, 2x cubed plus e. And so that I end up with 2y equals ln 2x cubed plus e. And then divide by 2. So y equals ln of 2x cubed plus e over 2. So that's my function. Y equals ln of 2x cubed plus e over 2. And somehow in there it'd be worth 5 points solving for y. So you do have to be able to do the algebra to solve for that y. And they typically do have an exponential function in it. It's not that bad. It's not very nice. And you know, it's a very carefully thought out initial point, that 0, 1/2, that helped us. It's kind of nice. If they'd chosen a different point, it would have been a pain. So, so let's talk about, go back into history here, pre-calculus. Do you remember there were 3 restrictions we had to know? There was a restriction for the functions that we were primarily studying. No zeros in the denominator, right? No zeros in the denominator, we know that. When it comes to square root functions, it has to be greater than or equal to 0, whatever's under the square root. And then the third one was logs. It has to be strictly greater than 0. When I say it, I mean what you're taking ln of, right? So for this domain question, so it says find the domain, and oftentimes they'll throw this on there worth a point or 2 of the 9. Find what's the domain here. Because what happens with these functions that you have this differential equation, you have a slope field, and you have a particular point. A lot of the equations they give you will be split equations. Like you'll have a curve above the x-axis and a curve up below. Like the function y equals 1 over x, stuff like that. So when you go to find a particular solution, you've got to know what the reasonable domain is for that continuous function that you integrate. Okay? So it kind of takes the problem's point out of it. And so they will ask you oftentimes for the domain and maybe ask you to draw a sketch of the curve that you just integrated. And it will be one of the branches. It's got to be the branch that corresponds to the domain and the particular point. So what's true about this is that 2x cubed plus e has to be greater than 0. So my domain calculation is 2x cubed plus e has to be greater than 0. And if I can solve that for x, can I solve that for x? Yeah, we can do it. It's ugly. It's kind of, you know, but we can do it. You'd move the e over, divide by 2, and one more step. Here's what I have so far. Cube root, yeah. So x, I mean, I've probably never seen anything like this before. This is it. So cubed root of negative e over 2. So that's just saying that the x values have to be bigger than the cube root of wherever that decimal is. And so it's everything to the right of that number that is in the domain. Okay. Let's talk about the range. I don't know that we're going to do the range right now on this one, but do you guys know the process for finding range? Remember? No. Maybe we should do it. We should try and do it with this function. I'm interested to see if we can do it with it. Sometimes algebraically you can't. Here's what you have to do. Here's what you have to do to get the range. So it's analogous to the domain. So what did we do to get the domain? We solved for y and looked for restrictions on x. Let me write that down. This actually, you really should know this. So to get the domain, we solve for y and look for restrictions on x. See, in the past, like in advanced algebra and even in pre-calculus, I'm guilty of this, is we sometimes figured out the range just by graphing it on a graphing calculator and looking at it. And the reason for that was because sometimes it was really hard or even impossible algebra to solve for x in terms of y and then figure out the range. Let's see if we can do it on this one. I think we can on this one. So to get the range, it's going to go like this. Range, just kind of take that. It's to get my range. I won't write anything yet. We're going to solve for x. Solve for x and look for restrictions on y. Okay, does that make sense? In terms of whether in practice it might be hard. So here we go. What was the original function? Oh, it's that e to the 2y equals 2x cubed. And then we had, it was over here. So we have y equals ln of 2x cubed plus e. So y equals ln 2x cubed plus e all over 2, right? Okay, do you think we can do the algebra to solve that for x? Yeah, I think we can. We probably could have even done it from the stage earlier on. It would have been easier, but here we go. So we got 2y equals ln of 2x cubed plus e. How do I get rid of the ln? E, so you exponentiate each side, so we're back to the e to the 2y. And exponentiating that leaves me 2x cubed plus e. So that's why I was saying it would have been easier from a previous step. That's okay. And then subtract the e over. So it's e to the 2y minus e. Divide by 2 is x cubed. And then the final step would be cubed root. So cubed root, oh, this is interesting. And 2y minus e over 2 equals x. So interesting. Are there any restrictions on the cubed root of something? Because there aren't. It's okay to have a negative under the cubed root symbol, right? So, and you could graph this to verify it, but there's no y that's going to be problematic here. Y can be anything. So the range is all real numbers, yeah. You remember how we wrote that with over this? What's that? Do you guys remember doing that? Negative theta infinity open on each end. So that's all real numbers. So we can do it for this one. That's interesting. So that's a pretty complicated function. But I've seen it on the AP exam. Typically they'll ask for the domain, and there's a reason for that. They could ask for the range, probably won't, but they could. You should know how to do it. But it's interesting because in Algebra 2, if you think back, if you were to go back, and any of you are mentors for Algebra 2, but if you go back, when they ask questions about range, it's oftentimes calculated aloud, and you're just looking at the graphic calculator, because it can be very difficult to solve for x in terms of y when you think about restrictions. But those 3 restrictions I mentioned just a little bit ago are the ones you got to watch out for. Are there others? Yes, but those are the 3 that we're going to see when it's seen besides that. So, any questions on this? Okay, that problem is taken right off of an old AP, so that's kind of the level at which you see it. This is taken out of the textbook, this example from the textbook. So here's another one. The function f is differentiable for all real numbers. Okay. It has to be able to integrate each side here, or at least it has to be differentiable over a certain domain. The point 3, 1/4 is on the graph of y equals f of x, so they're giving us a particular, or initial value, we'll call it. It's an initial value, a particular point on the graph of y. And the slope at each point, xy, on the graph is given by dy dx equals y squared times 6 minus 2x. You could probably just write down the function and the point and say, solve the initial value problem. And that's what this asks us to do. By what method? The only one we have. Separation of variables. I thought this one was kind of interesting. This is an example from the textbook. So how do you think we should separate these out? What should move where? So the way of y squared times 6 minus 2x. We probably won't want to distribute, right? We probably want to leave like this. So maybe move the y squared to underneath this. And then the dx goes over here. That look okay? And then you're going to integrate each side. So I'm going to rewrite this as the integral of y to the negative 2 dy. This is the integral of 6 minus 2x dx still. Alright, and what's the integral of y to the negative 2 dy? Going the wrong way. You're going to add 1 to the negative 2. So y to the negative 1 divided by negative 1. So just negative y to the negative 1. And then equals 6x minus x squared plus c. So it's nice having that 2 in front of the x there. You raise it up so you don't have the fraction. And I like to always plug in the point at this stage. You could solve for y. The nature of c changes, but I like to plug it in at this stage. So we're going to plug in, what is the point we're plugging in? 3 1/4. Okay. So let me rewrite this as negative 1 over y, and let's put our 1/4 in there. Okay. So and then equals 6 times 3 minus 3 squared plus c. So we are rewriting 1 to the negative 1 as 1 over y. And then we're just going to solve for c. Yeah, this comes out fine. This is negative 4. 18 minus 9 plus c. So what is c? Yeah, negative 13. Okay. So this is just the way I do it. I just like to plug in right away. Where I have the chance to make some kind of sign error or something. You could solve for y and plug in later. So here we got negative 1 over y equals 6x minus x squared minus 13. And then we've got to solve that for y. It's a really easy process if you're really good at proportional reasoning. Do you guys see this as a proportion? There's a lot of this that'll show up on these problems. There'll be a lot of this that you can do. So I can just swap these. I don't know if it's the extremes or the means. I don't remember, but swap diagonally. So the y comes up here, the 6x minus x squared goes down there, and you're done. That's what y equals. So there's our particular equation that has whatever the starting thing was as its differential equation in implicit form. So if you look up here, sorry, I'll come back to it. This is really an implicit form. We have a mixture of y's and x's over here. And we have, through separation of variables, found out the explicit form of the function that has that as its derivative and goes through the 0.314. So these are just initial value problems. So we're going full circle back to 7. Any questions? Let's try maybe a couple more, 2 more. Okay, I just have one more. This one, this comes from an AP exam as well. I remember this. And this one was really a problem. And I can tell you what the problem is. I remember because they give us results and we can look at. So here's the thing you want to do on this dy dx when you want to go ahead and factor out a -2. So I'm going to rewrite this as dy dx equals -2, and then we're left with y plus 3. And students who didn't factor out that -2, or students who tried to somehow separate this by adding or subtracting, you can't use separation of variables by adding or subtracting things up. That doesn't work. It's got to be a proportional sort of combination. So that's what you want to do first. And then the other thing that students messed up on this that really made it problematic is maybe leaving the -2 with the y plus 3, like actually moving this whole thing down. What they did makes it very problematic. Here's why. When I put the y plus 3 over the dy and it's positive into the first power, that is exactly an ln form. If you move the whole -2y minus 6 to the bottom, then you've got to be really careful. You've got to like use a u substitution. You got to be careful about how you rewrite that. But the y plus 3 is super easy to integrate. It's just ln of y plus 3. But if you have a coefficient in front of the x or the y when it's on the bottom, that tends to cause issues. So if you can avoid that, I would do that. And you leave the -2 up here with the dx. And a lot of students just didn't make that connection. So I don't know what to, as we go in practices, I'll try to point that out again. But you want to get a linear binomial without any coefficient in front of the variable down there with your y. And then that'll be an ln form. And these show up a lot. So now we're ready to integrate each side. As I said, the left-hand side is ln of the absolute value of y plus 3. Don't forget that absolute value. And over on the other side, we have -2x plus c. So that's what we have so far. ln of y plus 3 equals -2x plus c. And we're going to go ahead and solve for c. Why don't you go ahead and do that? Solve for c. Plug in the point. You see the point right here? You see why it's important the absolute values are on there. Makes a difference. So solve for c. What are you getting for c? I think I got it. Has an ln in it. It's okay. We're going to leave it in ln form. It's just going to be ln of 7 divided by, or plus 2. Ln of 7 plus 2. Because you're plugging in the 1 right here. Gives you a -2. Oh, and then add it over. And we get ln of 7, it's negative 10 plus 3 is negative 7. Absolute value of negative 7 is 7. If you left out the absolute value, that messes your students up on it. Okay, make sure you get that in there. So we said ln of 7, what was it? ln of 7 plus 2.
Plus 2.
Plus 2. Why did I write 2? Thank you, my editors. So now we got to plug that ln of 7 plus 2 in right here. So we've got ln of the absolute value y plus 3 equals negative 2x plus ln of 7 plus 2. ln of 7 plus 2 is just a number. Ln of 7 plus 2 is some constant. So, all right, and then if I need to solve this for y, I'm going to exponentiate each side. It looks like this. It won't let me write there. So if I exponentiate the left side, I'll end up with y plus 3. Leave it an absolute value for now. And then the other side will be e to the negative 2x plus ln of 7 plus 2. It's interesting how they rewrote it on the scoring guidelines. I'll show you how it's rewritten. We'll see if we can make it match up. But there it is. Y plus 3 equals that. And this is where first. Oh, that's my hint. That was the hint. My hint was to factor out the negative 2 first. All right. So now the question is on the absolute value of y plus 3. Can we now drop the y plus 3? The absolute value on the y plus 3. So can we drop the absolute value on the y plus 3? An exponential function. An exponential function. Are there any domain restrictions on this guy? Are we a nice continuous curve? Okay. If you were to graph this, function, it's a nice continuous curve. There aren't any issues. You can go ahead and drop the absolute value here. So if we drop it, we got y plus 3. Let me just write the final answer. It's going to come out. Let me do this with this goofy grid here. Won't let me write over it. So we would drop the absolute value. So y plus 3 equals this mess. And then y equals e to the negative 2x plus ln of 7 plus 2, and then minus 3. There's actually a way to rewrite this. You can rewrite this thing right here. You think of it as, let's see if we can do it now. I think, would you agree this is equivalent? Would you agree this is equivalent to the e to that whole thing to the power? We're reversing the rules of exponents. So, and then, do you know what e to the ln of 7 is? 7, yeah. And so, yeah, 7e squared. So another way to think about this is this was y equals 7e squared, and then times e to the negative 2x minus 3. And then if you wanted to, you could recombine these. So it would be 7e to the 2 minus 2x minus 3. I think that's how they had it written on the scoring guides. But any of these would be correct. At any stage that it's solved for y would be correct. The graders would just have to be able to read equivalencies. It's kind of nice to have it in this format for answering this question here. This is asking about end behavior model. And they asked that on that question. What is the limit as x approaches infinity of y? And this would maybe be a non-calculator. So what are you thinking about here? As x gets really big. So what happens as x gets really big? So as x gets really big, this becomes e to a negative power, which means you move it down. And as x gets really big, it's a really big number underneath the 7. Are you with me? Going back to the beginning of the school year and a little bit last year. It's the dominance thing. So we got 7 on the top over a really big number is 0. Okay, this whole term goes to 0 as e goes to infinity. 0 minus 3 is negative 3 done. I think this is worth a point. I don't remember which one they asked. If they asked that limit or this limit, they asked, I think, one of them. Okay, and then the limit as x goes to negative infinity. What do you think? it's going to go to infinity. It's just going to grow. And if you were to graph this, you'd see it. That it's infinity, but this was a non-calculator one. So 4 out of 6 of them are non-calculator. And this type of problem, separation of variables, shows up on the non-calculator. Okay, so I've shown you what I think are all like I actually showed you 2 out of 3 of the harder ones. So I'm hoping the cameras won't be too bad. So I'm trying to show you some of the ones. And 2 of them, 1 and 3 were from actually AP exams from past. One more connection I want to make here. This is kind of a segue into the final lesson that we'll be doing from this. We're going to look at the logistics model, and we're going to learn one other technique for integration, just one other. That's it for the whole year, and that's called partial fraction decomposition. Partial fraction decomposition. I mentioned that before. Okay, so, but before we go there, guys, you need to write this down. You might want to write this down, or listen. Yeah, you probably should write this down. The law of exponential change. Here's the deal, and we're going to revisit this next week again. But if y changes at a rate proportional to the amount present, that is, this is a blast from the past, we're saying dy dt equals ky. We call that direct variation. Direct variation. Direct variation is just y equals mx form, except this is a little different because I've changed up variables in terms of what's independent and dependent. So if you see, what this is saying is if you see a differential equation, and you most likely will on the AP exam, of the form dy over dt equals ky. So if you see this, if you were to write down just the abbreviated version of this, dy over dt equals ky implies a particular solution of this form. It'll be an exponential function. Okay, so that implies there's some other things in here that have to be true. But it says, and if y equals y naught when t equals 0. In other words, when you plug in 0 for t, that whole term disappears and the y naught is the initial value. It equals y. The constant k is the growth constant. If k is greater than 0, or the decay constant if k is less than 0. So what this is saying, and like I said, we'll revisit this. Actually, we're going to revisit it Monday. I have a little handout to go with this, but it's really helpful to know that anything of the form dy dt equals ky will always have as its particular solution an exponential function. So keep that in mind. It's like you know the end result, what it should be, and then you could use separation of variables to get it. We actually did that on one of the 3 examples we just did up. I think it's the one we just did. It was of that form. An example for it says, find the half-life of a radioactive substance with decay equation y equals y naught e to the negative kt. There's no calculus in this. This is just review. You guys remember half-life and how that works? So it says, and show that the half-life depends only on k. So the half-life is the solution for t to the equation y naught e to the negative kt equals 1/2 y naught. So what that's doing is setting this exponential equation to half of what the initial value was. If you can solve that equation for t, you'll have an expression for half-life, and it's a constant. It's always the same. Do any of you know what it is already? Just from your science stuff. Do you guys know what the half-life solution is to an exponential function of the form y equals y naught e to the negative kt?
Isn't it like 1/2 y x minus 1? Something like that?
Okay, well,
you take whatever
yes,
the remainder and you
well,
that's crazy.
so okay, let's just solve this equation. Let's just do the algebra here. There's it's a constant. So here it is. That would depend on x. This won't depend on any variable. It's going to be a constant. So what happens to the y naughts here? Cancel. So we have e to the negative kt equals 1/2. We're doing algebra 2. It's okay. So how do you solve that for t? ln of each side. So we take ln of each side. And then you take ln left side, then I get negative kt equals ln 1/2. And then t equals negative ln of 1/2 divided by k. In the textbook, they'll tell you in the textbook that half-life. So the half-life of a radioactive substance with rate constant k greater than 0, is half-life always equals ln of 2 divided by over k. That's the constant. Is this really equal to that? It is. I can prove it. You can prove it. So negative ln of 1/2, that would be negative. How do we rewrite ln of 1/2 using the properties of logarithm? Come on.
No idea.
See, ln of a over b is the same as ln of a minus ln of b. We have to remember this. So it goes ln of 1 minus ln of 2. And then, of course, it's over k. Okay, we're almost there. ln of 1 is 0. 0 minus ln of 2. And then distribute the negative sign, you get ln of 2 over k. So fancy. They make this statement in this section in the book. It's like it's an algebra review thing. There are actually some problems where you don't do any calculus in here. It's just dealing with exponential functions in it. But it's prepping us for what I'm going to do Monday and then Tuesday of next week. We're going to wrap this thing up with taking, and this is a kind of a Calc 2 sort of idea. It's in the BC curriculum. So, but the process that we go through relates to AB curriculum. So we're going to do. But we're going to take the differential equation form of the logistics equation. You guys familiar with the logistics equation? Well, it goes like this and levels out. Okay. So the differential equation form of that, we are going to use our techniques we just learned to integrate that thing up, and we will come up with the logistics equation, which is an exponential form equation. So that's where we're heading with it. So we're almost done with chapter 7. Do you guys eat Kleenex? You need to go to the Wellness Center. What if the whole calculus class showed up at the Wellness Center? They're all just kind of wadded up on the floor after. You come? No. You guys, you can do this. The crazy thing about calculus is the recall that's expected of trig and algebra. It's insane, right? I mean, there's a lot. This is the best algebra course you've ever taken. Serious. This is the best algebra course. The culmination. Okay, so it should be in your syllabus. What I need you to do for homework. It should be part of the yeah, so it's D. It's D, guys. So I don't know why I did it like that, but D it goes to 74. Oh boy, there were a lot of. I don't like it.
Yeah, exactly.
I don't know what I'm doing. Because like, no, the problem is that you'll be like, I'll do like put it on the board and I'm trying to write it down and I just start talking, but I can't write down and listen to what you're saying. So I finished writing down. I'm like, what was the thing you just talked about?
Right here.
Oh, I lost that.
Well, they're all, at least one of us got it. We have to separate variables. All the
Number 11I, 21, 25, 48, 49, 57, 8, no, like 57, 8.
Try some, guys. Let's try some for 10 minutes.
Mr. Round.
I'm pretty sure it was I missed it. I literally forgot. I literally forgot about
He was the first four.
I literally was like, I literally was yeah, I forgot the 1/2 part.
What are your views on Dwight? High school graduate. But it wasn't true.
I didn't
last semester, if you're not doing some kind of research, you can use your head targets as well. There might be one on there where you're not doing any stuff.
Yeah, I was like, they do stuff. I don't think they do that. I got the 1/2 too.
I used to, honestly, I was thinking about it. Yeah, I just, that's where my brain just like you do this with it's analogous to the presidency. And that think about the form that we get.
No, but then one because it's like okay, but like it's basically a president.
But in the Constitution, it's like no tactics.
Maybe which one? Sure. Yeah, I used to explain that to you before too, and I'm like, where are the money at?
That's really good.
My mom.
I'm so excited. Where's the monkey shirt?
I'll wear it tomorrow.
Monkey shirt.
It's not like
It's just a shirt with like a little writing. It looks like that. It looks exactly like that.
okay, that's just racist.
But you even said
Every time I wear it, I get racially profiled.
why did you wear a shirt? And then you go, like a monkey.
What are you talking about?
There's a monkey shirt. His grandpa got it.
Oh, yeah, Jason.
Okay, Mom, that's not how the election works.
So not So let's do number one. Okay. My mom is climate change. Well, she makes it before of doing tax returns. It was hard to well, okay. I wrote that. That's all. No, yeah, but that's literally like my mom said yeah, but the question is like, if they are, I vote. See the president, I can't leave. Yeah. I understand what and when I lose on the wrong side, I don't know. The people that they've done with their career. Oh, God, what I'm actually he said, like I can feel she said it's not necessary, but like I was like, if you go for an actor, should have pressed one of the right. You know, right. It's a really great actor. So far, it's like, no, but and then the monster is not decided. They're not decided. Some of them no. I know she. I know what she's saying. She wants to vote for Pete, but does she really? Is that what you guys about? Yeah, every time. Like the commercial for Prop 13 comes on, my mom goes in an instant rant about how people think it's the same as the old Prop 13. I'm like, Mom, I don't care. What's the Prop 13? It's like before it's more money to the school. Before it's like taxing like people. What was the proposition that everybody voted for? That like gas tax. Gas tax? Brexit. I don't know. I read it. I was like, yeah, I can see how like yeah, I vote for that. Brexit. We need Brexit round 2 of America. We're going to see it again. We're not repeating. Right. Thanks for that. Oh, wait, we have dude, I need at least 5 just to see it. This is the first chapter that I have no idea. That's me every chapter. Straight up. And then, like, right at the last page, I'm like, oh. Yeah, so I forgot. I forgot to put a 2. I forgot to put a 2 on number 2, and then I forgot to put a 1 in 18. Like, really he said you get, he said, I forgot to put, well, first I'm always no, it's not a 1/19. Because it's 1 over A and A was squared. For inverse tangent, it's 1 over A squared with small I. I didn't pull it out.
And then
But did it end up like a 130? So I really just I know this is going to be a I forgot to pull out. They try to pull it faster. Ah! Elbow! Just pull out the yesterday, I was going hammer, right? And it swung away from my work. You see those block switches? That's what I had, but then I'm like, I don't know. I fucking smacked that on your water bottle. Oh, okay. I'm sorry, my fault.
As when you said spirit that goes down the strings to that. But yeah, and then they go.
So then what? So like you saw I saw somebody with a tablet and looked what I no, well,
Or are you saying you have it
it would have to be Republican. Not voting for but in terms of like perhaps it's going to move through. Right. Yeah, I would there's another Republican or non-partisan like that. Look at you.
Oh, no, thank you.
Maybe you just did something wrong.
yeah, I have to go look up that up because I need to see what I don't know anything about any of the other candidates with them.
I feel like it's best for a presentation.
Presentation.
Yeah, let's work on a presentation.
Yeah, let me look here.